Hello, my name is Dinh Phan Huy from Orange. I'm the leader of the Work Package 6 Reconfigurable Intelligent Surfaces for Enhanced Sustainability and Security of the European RISE-6G project on RIS for sustainable environments for 6G wireless networks. I will present you the joint work of the partners listed on these slides. So here is the outline of my presentation. After the objectives of the Work Package 6, the methodology and the results, I will present the outlook. So the aim of Work Package 6 is to create innovative physical and MAC layer schemes to deliver data connection between the network and intended user with the desired quality of service, with trying to avoid or minimize undesired consequences, such as undesired energy consumption at the network side, undesired energy consumption at the smartphone side, undesired coverage, unnecessary coverage of non-intended users, who are exposed unnecessarily. Indeed, we have to take into account deployments of future networks in some areas with already very stringent electromagnetic field exposure thresholds due to stringent regulation. And we want to minimize undesired coverage of another type of non-intended user who is equipped with a device, the eavesdropper. So trying to maximize the desired and to minimize the undesired is trying to improve efficiency utility metrics such as energy efficiency, electromagnetic field exposure efficiency or utility, I'll come back to that, and secrospectral efficiency. And we believe that reconfigurable intelligent surfaces can help networks to boost that locally in some well-chosen places in space. So how did we proceed? So we started by defining this efficiency or utility metrics. So either you are considering a downlink data link or an uplink data connection. In both cases, you can define the energy efficiency metric as the sum data rate, that is the sum data spectral efficiency that is achieved, divided by the total amount of consumed energy. And then if you consider a non-intended user, eavesdroppers for instance, then you can compute the secrecy spectral efficiency as the spectral efficiency at the intended user minus the spectral efficiency at the non-intended user. Similarly, you can define the inter-electromagnetic field exposure utility or efficiency as the ratio of the data rate at the intended user divided by the exposure at the non-intended user. There is a special case, which is the one of self-electromagnetic field exposure utility or efficiency. In this case, the intended user and non-intended user are the same. The intended user is exposing him or herself with its own uplink data. So the next step is to define where the performance is boosted. So we introduced a new concept, the concept of area of influence, or AI. So this is the area where the metric that I have introduced before is significantly boosted with respect to the scenario without reconfigurable intelligent surface. In short, When you introduce a reconfigurable intelligent surface in this building, you manage to boost the energy efficiency or self-EMF exposure utility metrics in the light blue area. You manage to enable coverage in the yellow area, and in the dark blue area the RIS has no influence at all because it is too far or not illuminated enough by the source of power. Identically for secured communication, here the RIS enables to increase the coverage with a given minimum secrecy spectral efficiency value. It manages to improve the SSE metric in the light blue area, and in the dark blue area it has no influence. This is very important because a RIS doesn't have a coverage area, it has an area of influence over an existing coverage. Then we try to identify requirements in terms of architecture and control signaling that are linked to the introduction of this new type of device or node, the RIS. So how did we proceed? We analyzed all our PHY-MAC schemes in the project. So here is a non-exhaustive list of them. And we counted for each scheme. We listed for each scheme which interfaces between nodes, base station and RIS, uplink, downlink, base station and intended user, base station and non-intended user, uplink, downlink, RIS and intended user, RIS and non-intended user, all interfaces, uplink, downlink. We listed all of them and we checked whether they were necessary for the scheme to work. Were they needed for control signaling? And what is striking is that the base station is giving a lot of orders to the RIS. So it appears clearly that the base station is kind of the master of the RIS. So first results, we analyzed also the schemes in terms of protocol duration, and what we discovered is that almost all schemes need their protocol to be run within the coherence time of the propagation channel. So channel sensing, control signaling, and then data transmission, resource configuration, everything has to be done within the channel coherence time except for few schemes. What we learned as well is that in all schemes, there is a reflecting mode at the RIS and a receiving mode. This receiving mode is to listen to pilots and control signaling mainly from the base station, sometimes from the user equipment. Some schemes need some optional modes like transmitting pilots and control signaling, or a transparent mode, a mode where the RIS is it's almost like it was not there. And the last lesson learned is that the base station appears to be the master node of the RIS, which is in most schemes kind of a passive relay node and a slave node. So the results. So we have produced quite a lot of novel PHY-MAC schemes. So here is a non-exhaustive list of them. To provide downlink and uplink data connection. So there are several schemes that manage to do it whilst trying to minimize exposure on a non-intended user in downlink and uplink. Several of them, only one is listed here, tries to avoid self-exposure. Some of them avoid eavesdropping in downlink and uplink. And one of them is really focusing on energy consumption at the network side. I want to highlight that almost all schemes take into account energy efficiency in their optimization. So this is all for WA package 6 up to now. The project is not finished. It will end on December 2023. So currently we are continuing the work on performance evaluation based on simulations, area of influence characterization based on simulations. We are also working towards experiments. And I invite you to see our last results on our last deliverables and publications on the RISE-6G European project website. Thank you for your attention.